Welcome to the Bytecode. I'm Hiro Shafu, and today's episode is about writing some invariant testing with Alex. Alex, thanks for being here, man.
Awesome to be here. Well, I'm about
For
to
sure.
hack you, obviously, as we were talking about.
Yeah, Alex was sending me some links that I need to install, so I'm just verifying to for myself. This is the first time I'm actually gonna do stuff on the podcast. So first thing is installing Echidna actually.
Yeah, and this is going
Uh,
to be the most painful thing. First of all, um, it's funny how people just want to be able to curl stuff like with Foundry, and they don't bother to verify stuff. But once you
th-
send them a GitHub URL, they all get super paranoid. But
That's a good point, man. That's a good point.
it's not
But
even
just
my
out of
original
context,
point.
just the context, this is the first time we meet, Alex and I don't know if he's North Korean or something. So, so yeah, just double checking stuff. So I just brew installed Echidna.
That's gonna take literally 4 hours. So that's why I was sending you the binaries. It's gonna download HEVM, it's gonna download HTTP, it's gonna literally rebuild the history of the web before it compiles. That's why I was sending you the precompiled binaries, which are built on a CI/CD by Trail of Bits. The alternative will be to use Docker. You can get their Docker container from building secure contracts. That's probably
Fuck Docker.
faster.
Fuck Docker.
But
Fuck
to be
Docker.
fair, installing Echidna is unnecessarily complicated. And hopefully soon we'll have like a URL where you just do something like uh, get Recon Echidna and it just installs it for you. But I haven't found a developer that can do that
Dude,
yet.
maybe it's a bit better idea to just if you do it this time because we only have like 45 minutes left.
Okay.
Uh, but next time, okay, next time I'm writing microlent, right? And we're gonna do some fast testing for that.
Yeah, next
Um,
time we're gonna do the one key invariant, the Euler invariant, the $1 billion invariant for microland. So I guess this
nice.
time I'm gonna talk about building some invariants from microstable. So I guess I'm
Yeah.
gonna share my screen.
Just for context, microstable is the best stablecoin implementation ever invented in the history of DeFi.
We're gonna
So,
need 2 hours to debate that. We're gonna need 2 hours to debate that. The lack of redemptions, lack of dynamic interest rate puts it a bit behind a few things.
no
But
interest
it
rate.
definitely is a
No.
good learning project.
Yeah, true. No, there are actually some smart people who would argue it's not even a stable coin because you don't have interest rates, but I'm gonna ignore that for now.
Yeah, I would ignore that as well. I don't think that's a fair statement. But as of now, all I did is I got the code and I'm building it. And what I'm gonna shill, because obviously I'm here to show kind of my work at Recon. But basically, the first thing I'm gonna show is that the second we have an out, we can grab the files, and I'm seeing manager, Oracle, etc. And then I can go on Recon under tools slash sandbox. We basically have this free to use website where I can just drop an ABI and then click this button. And it's basically generating all of the invariant testing scaffolds that I'm going to use to run the tests. And so in these 3 clicks, we basically saved you about 2 hours of work because now all I have to do is just set up a test folder. Like I'm gonna do test, and then I can just download all the files. And basically, I can just drop them. Let's see. The most difficult thing is how to drop them in VS Code. And then once I've done that, I just rename it to Recon. And then I'm gonna have to fix some compilation issues, which tends to cause a bit of panic to most people, but it's actually not that big of a deal. We'll just struggle through it for a moment. The first thing is we don't have a import properly set up. So I probably need to grab the manager from src/microstable, which by the way has kind of this alternative pattern where you don't import each file. And then I need to install Chimera, which is our framework. And if you don't know how to install it, you can just click here on installation help. But basically, I just have to run this command to install the extra package. And what Chimera does, which was invented by Antonio, my co-founder, was it basically connects Foundry with Echidna and Medusa, which means that all we have to do is write the Foundry tests in a sense, and then these tests will be automatically compatible with the other tools. I'm gonna go over that in a moment, but at this point, all we gotta do is get Foundry to compile. So let's see what's wrong here. I guess the remappings. So what is it? Foundry remappings dash remappings.txt. I guess it's forge remappings. And we're missing Chimera. So this is at Chimera. And then we just need to set up the compilation for the microstable. So we see that we have a constructor for WEF, SHUSD, and then an Oracle. And just for now, just to get to compilation, I'm just going to put free address zeros. And the fact that the conversation feels a bit jagged and a bit confusing is kind of an indicator of our current status for invariant testing, which is that the technology is extremely powerful. You can do a lot. I've done a presentation called FuzzFest, and I guess I'll take a moment to talk about it. But basically, we did this event called FuzzFest, where we talk about the blue side, the red side of invariant testing. And so, I mean, we've identified a ton of critical bugs, and the best use case for which I can shield invariant testing is to maximize impacts. For example, if you have a rounding error, you can just set up the tool and then you let it run in optimization mode, and it can tell you what the maximum rounding error or impact you can have. And so that's something that is really difficult to do with manual review. However, as you'll see, as I go back to the code, it feels like I'm doing basically this menial task just to get to that point. And this is something that is still completely unsolved. And I think once we can solve it, we're going to be able to have everybody to use the tech. And then on the other end, if you can just bear with me, in dealing with the bullshit, I'll show you how cool this becomes really quickly. But does this make sense so far? What we're doing, we're just getting to compilation, right?
Mm.
And so what we're gonna do now is most often we will look at the code first. So in this case, we have these free contracts. We basically have the debt token. We have the WEF, which will be the collateral token. And then we have the manager contract. So, and we also have an oracle. So this means that in terms of stuff that we should do, so I guess I'll do a quick to-do list. We probably need to mock the oracle. We need to mock the token, unless you have a test token. And then we need to actually test the manager, because fundamentally, this is the real test. And then the other two things are just stuff that we gotta do to kind of get to the testing. Does this make sense?
Yeah,
So let's just
definitely.
quickly get that done. I'm gonna go create a folder called mocks, and then I'm gonna create a mock oracle. So the interface is latest answer like this. So I guess we'll do contract mock oracle, and then we'll do function set answer. And actually, we can just set this as a public uint 256, and then set answer will receive a value, and it will basically set it to that amount, or just the price. And so obviously here, as we define this mock, we are taking a massive trade-off, and the trade-off is that we're not testing for revert, we're not testing for additional complexity, and we're also not mocking for arbitrage. This is something that if you spend a lot of time with oracles, especially in stablecoins with redemptions, there's always a ton of arbitrages, and so most of the times you want to test for those. But in this case, we'll just get it done with something quick and dirty. So this is basically our mock oracle, and then the other one will be our mock token. And I'm seeing that you use Soulmate, so I'll grab that as well, and then I'll do contract mock token is ERC20. I don't recall what I need for the constructor. Probably this, so let's copy it directly. And then we'll just expose a function mint address to UH56 amount. We'll just mint 2 for that amount, which I think is all we need for the token. So at this point, we just gotta figure out if we can get to compile. We don't have a visibility, so let's do external. And so at this point, I will just commit just for the sake of tracking stuff. So this will be initial setup. And once we have this initial setup, let me remove the thing before I push to your code. But basically what we gotta do now, going back to our to-do, is we have mocked, so we need to set this up. So we go in the setup, and I guess I'll briefly explain why I'm doing this. But the theory behind the Chimera framework is that you have a setup contract that handles your constructor, and we put it in a setup so it's reusable. And then you have a critic tester and a critic to Foundry. The critic tester will be called by Echidna and Medusa. I can call it even now, and I just paste the command and run Echidna. I guess I'm file doesn't exist. We can try Medusa, I guess, in this case. But basically, we would there we go. We don't have our config. So something I forgot is we have to bring the config files in the root of the folder so that we can use them just for convenience. But by doing this, I'm now able to run both Echidna, Medusa, and Foundry. And what we're doing behind the scenes is our framework is automatically compiling with Foundry. And it generally you would have a slightly edited Foundry file that makes it so that our deploy contract is at the same address for Echidna, Medusa, and Foundry. So that when you run this setup file and you deploy your targets and the contracts you want to test for, they will all be in the same predictable address, which means that any sequence we break with Echidna can be reproduced with Foundry. And so what this looks like, if I can show you the work we've done in the past, we have it on our website, getrecon.xyz. But basically we have these trophies. An example would be the work we did for Centrifuge, where we run Medusa in the cloud, and then Medusa breaks a property. And then from that property, we get a sequence that we can then test in Foundry, because most developers are very familiar with Foundry, but they're not as familiar with these tools. And so what we do is we force you to do the minimum amount of work to go back to Foundry. And that's kind of the point that I'm going to show you. So does it all make sense so far, Shafu? I can't hear you. I think you're muted.
Yeah, I was saying just, it's the setup, just, the pain we have to go through.
Exactly. It's
Nothing
just
really
a
on from there.
grind. So let's grind it out really quickly. I'm going to go through these constructor, and then from there, we're going to go into the more interesting stuff. But at this point, we covered the setup, we covered the critic tester, the critic to Foundry. So let's just get to the compilation. From your setup, we have the SHUSD, which is basically the debt token. So I guess we'll call it SHUSD. Then we should have a Oracle. So, or I guess WEF we also have. So I guess let's import the mock Oracle from /mocks/mock Oracle. Then we'll import the mock token. And so these are going to be our mocks, which we could also call WEF, I guess. Let's call it WEF for consistency. And then we will have the Oracle. So now we can deploy the Oracle. We can deploy the WEF. Then we most likely need to deploy the token as well. And we may need to figure out how to grant permissions. I guess the permission is given here on the manager. And then SHUSD is set up deterministically. So we're going to have to cheat in order to set this up. We'll basically do a deployment in this way. And then because the order is deterministic, we can then hard code the addresses at a later time. And I think what's going to happen in this case, because we don't have this Echidna YAML is not set up, we may run into a bug. So I'm going to avoid that by just going on create Chimera app. If you always use the latest version, which is on our GitHub, you'll see that it has these extra two fields called deployer and contract address. And by adding these two fields, we are making sure that our tester contract is in the same address as the tester contract on Foundry. And so now I can use Foundry to basically grab the addresses deterministically. So here I can just put another 0. And I think I just gotta go on Critic to Foundry, which is our Foundry debugger. And then I'm gonna basically just grab the addresses that I need deterministically. And I think WEF is gonna be fine. So let's see. This deployment is gonna be WEF, SHUSD, and Oracle. So this is WEF. SHUSD we will have, so this is going to be fine as well. And then this is going to be the Oracle, whereas the manager is not predictable, so we have to run Foundry first. So I'm just going to write how to write a test just for convenience in case I need to run it again. May as well save that so I don't need to rewrite it. And then I'm going to figure out what's missing. Maybe we're missing console. I believe it's in test now. And so SHUSD will be deployed here. Manager will be deployed at this address. So I can simply pass this address in this way. And this should make it so that it's going to work. I guess I could just do assert EQ on SHUSD dot manager. If it's public, it is. So assert EQ SHUSD dot manager must be equal to address of manager. And this is a Foundry test, so it only works for Foundry. Whereas if I grab the same idea and I put it here, then what's going to happen is the same test will be run for Echidna Medusa. And because we use it's a different framework, which is called Chimera, but we don't have access to this tester. We have to call it just a T for true, and we just test it in this way for a simple equality. And so this makes it so that the test is always run, oh, I guess we don't have it here, so I guess I'll just assert. But this is just the slight difference is to make this compatible with all the tools, we have to have our own framework, and we'll see how that works in a moment. But fundamentally, Foundry is compiling, so I'm going to go back to running Echidna. And as long as Echidna runs and it doesn't throw on deployment, it means that we have the same tester and the same setup. And so this is a pretty positive starting point. it means that we most likely will be able to make some progress. So from here, this is where things get interesting because we have the setup, which is you have to provide. Then we have our boilerplate. And so now we can look at the two key contracts, which are called properties, and the other one is called target functions. So the target functions is where we will put all of the handlers that will call in order to move the state, or what we call it the story. I guess we'll basically just have this sequence of events. And then the properties is where we can test whether a certain property is maintained. So this is where you as the engineer, as the creator of the project, you will most likely want to start by giving me some pointers. This is how we typically do an engagement at Recon. We have the developer give us the initial properties. And then after having gone through a first iteration and then having read their code, that's when we can also write our own properties. But I think a global property here will be
Okay.
that the collateral ratio of the system is always above a certain ratio, or perhaps we could simply say that any user below a certain ratio is liquidatable. So these are the type of stuff that we would kind of brainstorm. So what do you have in mind for properties we could check?
Alex, can you hear me?
Yep, I can hear you. Can you hear me?
Yeah, the internet, the connection is horrible.
Okay. So, but
Super laggy for some reason.
I can hear you now, though. Looks fine.
Oh, okay, can you hear me again?
Yep.
Okay, weird. Okay, so we want to build some invariants, right?
Yeah, more so than invariance, which means that it's a property that always holds. We probably want to start by just writing some basic properties or sketch some ideas. And then from there, that's going to inform us, and it's going to inform kind of the rest of the code that we're going to write, because some of these properties are easy to specify in writing, but they're actually hard to code. Does that make sense?
That makes sense. Okay, what are some properties that are always true? So, for example, when you burn, um, when you burn tokens, the for a user decreases the exact amount for the address to minted mapping than the actual token burns. Is that like a property you could fix?
Yeah, and so this is a good, this is also a cool insight into how most engineers think about properties when they first begin. But the second you start talking to me about this, what I will start with will be even a more broader property, which will be that the sum of all the minted tokens is equal to the total supply. Is that a valid property? Or do you think that will break eventually? I'm no longer hearing you.
Yeah, can you hear me again?
Yeah.
Okay. I was saying one other property would be you cannot mint new SHA-2USD if you're under the collateralization ratio.
Okay, and this is what we call a doomsday property, which will be a property that anytime that can be done, it basically is a critical bug. And so you're basically specifying a behavior that should never happen. Whereas this would be more of an accounting property. or a global state property, where you're basically specifying how the state should behave. And so maybe we can think about one more. It could be that after a liquidation,
When
the
a,
user has zero. Go ahead.
exactly, yeah. When a liquidation happens, minted and deposited are reset.
Awesome. And so there's many ways to write this, and obviously we're also limited by time. So this is what I would call a stateful fuzz. Is basically not a real invariant in the sense that this is just tightly coupled with what happens. It's expressible as a before-after check. We could go through many hoops to test this, but there's also a very simple way, which would be to go directly in the target function. And then given the target function, we will simply inline the test here. So we will simply say, again, in this case, we can use the EQ quantifier from our tester. But basically, we will say manager dot address to deposit of user, and then we will just say that that's equal to 0, must have reset, and then we will do the same for the other check. And so the beauty of this is that we basically wrote what is a foundry test, and I'll show you in a moment. But now we also inlined these two properties, a stateful fuzz. And so we effectively are writing just foundry tests, but the way we're going to use them is going to be a lot more powerful than that. I'm pretty sure we need to approve stuff. Does this transfer? Yeah, this transfers token. So most likely we need to, let's just for the sake of time, we could have a separate contract that handles donating WEF, minting WEF, donating SHUSD, etc. But what we can do here is we can just mint to ourselves. We can mint, I typically like to mint type 88.max because it tends to be a fairly realistic value. Because many times you could test for, oh, sorry, type uint 88.max. But basically it's a fairly realistic value versus to type uint 256. Because many times you will want to test for overflow, which if you just put the maximum value, it's not going to be helpful. And then the other thing is, since we're using address this, we can literally just wef.approve the manager, which I'll put this function below. But basically we'll just approve it for the max amount so that we are able to perform stuff. And then I'm assuming I don't need permissions on SHUSD because it will actually create a bunch of denial of service. So I'm pretty sure this should be sufficient. And so this is where things are going to get interesting now, because on one end, what we can do is we can go fully blind and just run Echidna. And what Echidna will do is it's just going to grab this setup. It's going to grab our target functions, which currently are calling burn, deposit, liquidate, mint, and withdraw. We're basically doing all of this stuff. And I think we are just limited by the number of tests. So I'm going to change the config in two ways. I'm going to use format text, so it's not a UI, but it's just a text. And then I'm going to use test-limit to maybe 10 million. So 100, 1,000, 10,000, 100,000, a million, 10 million, so that it runs a bit. And what Kidna is really doing is it's basically going through all of these handlers, trying all these sequences that are somewhat meaningful, and it's basically trying to get them to work. We're getting this error because some of the corpus was run before I changed the Echidna file, but this is not a huge deal. But the worst thing I'm seeing is this corpus being stuck to 4, which means that most likely we're not really doing anything meaningful. And so this is where the work we've done with Chimera is really cool, because instead of just being in the dark, basically, and I'll show you the normal workflow will be to basically stop Echidna, wait for it to generate the new corpus, and show you the coverage report. So this is what we do on day-to-day when doing our job. We basically go on the target functions, and we just verify how the stuff works. And so to make a long story short, whenever we see red, it means that this line is not being hit. We're seeing a R here for reverted. And so what this means is that we have to investigate by going in the manager.sol, or manager, I guess, the contract. but most likely we'll see that either some of this stuff is reverting, and so it may simply not work, and then some of this stuff is definitely failing here for a myriad of reasons. I think the biggest one is that we set the oracle to have 0 as a price. So the way we would make the oracle work is to basically go back to our sandbox. So I'm just going to grab the ABI for it, mock oracle, and then I'm going to go back to the sandbox. And in this case, we only need this, so I'll just grab the function. But when we have a lot of handlers, we tend to separate them into separate files. But in this case, we can just do this. So this means that now we have a price. So most likely we should be able to deposit and withdraw. But what we can also do, because we have this combination between Echidna and Foundry, is we can actually just set up a demo here. So I can go and perhaps run some of the functions. So the first one will be manager deposit. So maybe I'll deposit 118. Then I'm going to set a price that is non-zero. So let's say I just set the price to 118 as well. And then perhaps I'm going to try to borrow. I guess it's going to be mint. I'm going to try and mint, let's say, 118 divided by 2, or maybe divided by 3, just to see if we can go through the API path. And this is going to help us. I guess this is not called more oracles. This is called just oracle. But this is going to help us quickly figure out if our handlers are able to reach meaningful coverage. I guess here I just have to what solidity is special. But basically, we're seeing a revert here. So this means that, obviously something went wrong. Let's see what. In this case, I'm seeing manager mint, the amount, latest answer is this amount, and then we're getting a revert. So maybe there are no comments as to what is happening, but most likely the collateralization ratio is going to be lower. So let's see, this is time 1e10 over 1e18. So the oracle is supposed to actually be with 8 decimals instead of 10. But let's see if this makes sense. No, we're still getting a revert. So let's try putting it to a very big number. But this is an example of something where maybe I'm misunderstanding the code a bit. But it feels like something is off with the logic, because obviously I deposited 118. I'm assuming this is the price of the value that I deposited. So I believe I should be able to withdraw stuff, right? Doesn't it feel a bit off that this is reverting?
Yeah, it does. Manager deposit. Maybe try to mint one way. Just try to mint one.
We can definitely mint one, and then if that fails, we can also decode internal. Hopefully it's going to show us the internal call. Okay, so we were able to mint one. Let's see if I try and mint again 1e18 divided by 3, because I believe the collateralization ratio was 150%, so this should be sufficient.
115.
But we're basically seeing that the collateralization ratio is 3e16 when I try to mint 3 whatever e17. So let's see. Minimum collateralization ratio is 1,5e18. So technically speaking, on a 1e18 price, I should be able to get, let's see, what was it, 1.5e18? So 1e18 over 1.5e18. So this is what I should be able to mint. Let's try with a 5 here. Let's see what we get. So whenever I mint this ratio, I'm getting 1.5 E12 as my collateralization ratio, whereas I would expect that to be 1.5 E18.
What are the decimals of the mock oracle?
Uh, there are no decimals, it's just arbitrary value, but I set the answer to 1E18. Would you want it to set to 1E8?
Yeah, 118 is way too large. Like the oracle, I think, returns 8 decimals.
But in this case, we get an even lower collateralization ratio. So maybe, maybe I'm missing something, but I feel like required that the collateralization ratio is greater. So let's see what the collateralization ratio is. It's the amount minted times the price over 1E18. So this is the amount minted. So this will be 1E18 times 1E8 times 1E18. So this basically becomes nothing. So this will be the amount
Yeah.
deposited, which was 1E18, over the amount minted. So address to deposit. So this will be 1E18 over this amount. And so it is 150 units. So most likely we need to scale this down by 1E10 so that it becomes, or actually maybe by even more. Which I feel like there's something off with the UX of the stable, but most likely it's my misunderstanding. So I'm just going to divide this by 118, and I think this should work. Although I think we don't have the precision for it. So maybe let's try again, minting just one. And in this case, we don't make it because we need the oracle to be of higher precision. So we literally need a ton, which I don't know if something feels off about it. I guess if we were using, I guess
The
we'll
mistake I
just,
did with the decimals.
that's the type of stuff that typically requires a bit longer. But to go back to kind of the a bit easier stuff, what we did is we basically showed that the fuzzer can reach this state. And from my perspective, what I will do then is I would actually go and investigate this ratio so that we always prove that we can never under collateralize the assets, because I feel like this is something to investigate further. And most likely, even just in investigating, we will change just the feel of it. I feel like it feels off when I set the price to be 118 and I deposit 118, that I can only mint one way. Whereas my expectation will be that if the price of my asset is 118 and I've deposited 118, I should be able to borrow 118 divided by 1.5 times, so 0.66 of the asset. So I feel like there's something off there, but what we will do there, if we had more time, we would investigate it so that each mint is never causing an insolvency, and I'll show you how we can do that in a moment. But basically, let's go back to the flow, which will literally be that we were able to run it with Foundry. If we were able to run it with Foundry, we can run it with Echidna. And so now we are using a more powerful tool for the job. And then if we were to be able to break any property, so an example in my case will be, and I guess I need to run it with the previous command, which was here. But basically, an example property will be that, let's see, for example, we would want to get the total supply. So this will be a property. So we can test this by simply writing a simple function such as property check supply. And we make all of our handlers public so we can test them in Foundry as well as having them called by Echidna. And then we will simply grab the sum of all address to minted and then compare it to the total supply. So in this case, we don't have an actor manager, which is an abstraction we would have in our testing. So we only have our own actor. So this means that we would have manager dot address to minted of address this needs to be equal to the shusd dot total supply. And so we will simply put an EQ for our tester. So instead of doing equal, we just set it up in this way. And so we will say sum of minted matches total supply. And so now we can simply stop the fuzzer after having written that. And the work that the fuzzer is doing here is actually not going to waste because it's being stored here as new coverage and new reproducers. And it makes it so that anytime we rerun it, the fuzzer is a bit more efficient. So just for the sake of demo, now I'm gonna stop it again and I'll just write the property in the incorrect way so that hopefully that shows us a scenario in which we break the tests. And so I simply, put a -1 here so that the math should be incorrect. And the second this breaks, you can see that Echidna finds this random sequence to break it. It's a crazy big one. But what's happening in the background is Echidna will just shrink the sequence. And then once I stop it, it's going to be able to generate a very simple sequence. And then what we can do through our tool at Recon XYZ/tool/Echidna. I feel like I'm lagging. Can you hear me? Maybe now. I think you're muted.
Yeah, I'm sorry, Alex. The internet is insane.
It's crap. But basically, what I'm gonna do is I can just grab these logs and copy them in our tool, and we basically get the Foundry repro. So this is a log from Echidna, another tool. This is a Foundry repro. We just copy it. We go to our critic to Foundry, and now we can quickly test this broken property with Foundry, for example, with -vv, with the code internal, so that we have all the conveniences of Foundry while having used the tool, which is Echidna, to break the property. And so this helps you kind of show our workflow where we use kind of the right tool for the job. We like Echidna a lot more to generate sequences and break properties. And then we like Foundry a lot more to debug them and to figure out the interesting stuff. Okay?
Yes.
Awesome. And so I guess if we go through more ideas, we have a property check, which is pretty cool. We should have this is effectively a doomsday tester for not testing, or rather for not being able to mint when we are under the collateralization ratio. So the way we will test for that will most likely be to do the following. We will basically create a new tester called doomsday cannot over borrow. And perhaps we will put a uint256 amount. Then we will call the manager to grab the collateralization ratio of us. And basically, this will be or I guess CR. And then we have to assert that the CR is below this, so we're liquidatable. So we will say that CR is less than manager, but minimum collateralization ratio. And this is where, by the way, we could have a discussion about the less or less than equal. So the specification is really important. So if you just quickly hack it, you can end up leaving a bug here if you don't spend enough time thinking about it. I'm just gonna do the less than equal, or the less, but maybe this should be less than equal, or maybe let's do less than equal and see what happens. And then now this test will only be tried when we are in this scenario, because that's a key difference with fuzzers versus Foundry. The fuzzer will ignore reverts. The fuzzers only look for assertion failures. And so now this test only happens here. The second trick will be that at the end of the test will revert. So this is a stateless test, which means that even when it succeeds, it reverts. So it doesn't create any extra changes. That's because we may not want to have multiple ways to borrow, because that means that if we start tracking or running inline tests, we have to maintain a ton of code. Whereas if we just revert here, we can just run this as an extra test. And so here, as I said, I have the precondition. So now I'm just gonna go and mint. And maybe I can also withdraw, but we're just gonna mint. So we'll do try manager.mint AMT, boom, catch. And so the catch case is ignored. We don't really want to do anything. Whereas here, we'll just assert a failure because this should, or I guess we just put the name, this, that it's, we should always fail. We should never be able to over borrow. And so perhaps by having introduced this less than equal instead of the less than sign, perhaps we actually may find an edge case here. I'm not fully confident, but basically this test makes it so that anytime we're able to mint, or anytime the fuzzer is able to build a sequence like this, it's gonna flag it to us. And then even though it's flagging it to us, this test is very easy to maintain because it fundamentally doesn't even if we put a ton of stuff here like mint, burn, withdraw, etc., we're reverting at the end, making it so that this never fails. And so the way you will test for this will probably be to comment out the require. So that way we do effective mutation testing on this. But this gives us a good sense that the test is actually working as intended. Because you may believe that because there's a revert at the end, this will not get tested, whereas the fuzzer literally broke it in an instant. And so then we simply stop it again and we grab our repro. So we go back to the scraper, we scrape it, we grab it, and then we have a new repro for Foundry. And so this way we can then debug it, etc. In this case, it's just a fake test, so it's fine. But that's kind of the entire flow where fundamentally you go through some of these key ideas, and over time you try to improve them. And so I guess the last test that I can show you, which I think is key, and I think for Microland this is going to be like $1 million test, but it will basically be that the system can never be made insolvent. And so the way we will do that will be to most likely have a test that does the following. The first thing will be to verify the system is healthy. Then we will do something. And then we will verify the system is unhealthy. And so there are many ways to do this. And if we add, if we could have the fuzzer do this, with an arbitrary call, we would actually do it in this way. We will do something like check never self-liquidatable. And then we will pass some sort of a function signature, basically, like a bytes for, or I guess even bytes memory data. And then we will basically do something like require. We will require that the system is solvent. So in this case, it will be the opposite. Collateralization ratio is higher than the minimum collateralization ratio. And then we will most likely assert that anything we call, say, will be address.manager.call data with success. So this will be bool s. We basically will always assert that s is false. So no call can succeed at this point. Although, I guess I kind of went on a tangent, but a better way to actually write, and this could be maybe done with Almos, which we actually support, but it's a bit niche. Whereas a more standard way to do this will be by adding ghost variables, which will simply mean that we go to our before after, and perhaps we can have a simple bool is liquidatable. And then we basically just grab a before dot is liquidatable, and we just grab the same check we did here. So it will basically be A user is liquidatable if their collateralization ratio is below the minimum collateralization ratio. So in this case, we'll use the strictly less than. So if the collateralization ratio is less than this, we'll assert that they are liquidatable. And then we will put both checks on the before and after. And then we will simply, we can basically create a modifier called before after or with ghost. That's typically how you would call it, which will basically do whatever. And then it's going to call both of these internal functions. And then we can go to our handlers and set them up here as a modifier. We can also just do this, by the way, public before after, etc. And so this is where you wouldn't want a test like this to become to have the before after. That's why you would want to revert, so that this is basically a meaningless test. Because otherwise, once you start having all this extra code, it becomes a nightmare to maintain. And then once we've done this, though, we can remove this entire test. We can go back to the properties, and we can have a simple function property never self liquidatable. And the property is beautiful, and it's basically gonna say that the if you were liquidatable before, so if dash before dot is liquidatable, or rather if you weren't liquidatable before, then we are simply assert that you are not liquidatable after, meaning that no user action allows you to become liquidatable, meaning that there's no way to possibly lock in bad debt to the protocol. And so by having this check and having these handlers, probably okay. This is a bug with our builder that we're gonna fix soon. But basically, the before after needs to be added in a different way. We fixed it here, so I'm gonna fix it real quick. But fundamentally, once you've written this setup, kind of the rest of the code falls into place. So let me just quickly see what the issue is. Before after just needs to be set up, and then target function needs to be properties without before after, and then most likely properties needs to be before after. Properties is before after and assert, and then setup is setup is just base setup. Okay, let's try again. And so in about an hour, we went through kind of all of the ideas. Obviously, the experience of having done it many times. I think I did 14 different suite this year, a real suite for customers. So obviously, the experience is makes a big difference. Many of my team members now, they went for at least 6 suites themselves. So Antonio has worked with Size, Alberto has helped recently, but Nicanor and Simon, they worked quite with a lot of customers. And what I've really seen is the first free suite that you write are just a complete disaster. It's just really difficult. But then once you really get used to it, things really change really quickly. And you can see me, I can scaffold any suite in about an hour to at least get some coverage. And that's where things get really interesting, especially when I pair them with our pro version of Recon, which is basically here at, I'll show the staging version just because the pro one is using it for a customer. But basically, what I can do as it's my company, so I can literally just upload a repo. Let's say we had uploaded the test to your repo. I will literally just paste the URL and then toggle Echidna and do whatever mode I need. And then I can just run this in the cloud, and basically I can just check the report. And a report, this one is a demo we did for Euler for the governance fuzzing, which is a new feature we released. But this is kind of what a job result looks like. It basically gives you all of the key stuff from Echidna. and then it automatically converts every broken property to Foundry, so that most of our customers don't need to really use the tools as long as they can maintain the suite. And it's we're basically making it so that as long as you accept kind of our trade-offs of writing in Foundry, using Echidna and Medusa, we made it basically as easy as possible to go through this workflow that I showed you, also while leveraging, the cloud, so that you don't need to run all of this stuff locally. Does that make sense?
Very cool, man. Very
Yeah,
cool.
so maybe we actually found a bug here. So we have never self-liquidatable. In this case, it's actually a meme. It's not a real bug. But basically, we can go back to the scraper. We get to the repro. I guess I copied it wrong. Let me try again. And now we should be able to repro this, and we can see one key aspect of the self-liquidation, which is that whenever you can sandwich the oracle, the self-liquidation is property doesn't work, right? Because if you can set an answer, mint, and then you can just change the oracle, you're able to break this key property. Whereas, and this is also why projects like Euler, they have a delay on the self-liquidation, because that makes it so that even if you could sandwich the oracle, you still need an extra block for setup. However, for our microstable test, what we will do is we will simply go to this and remove the before after, because we will consider this as not a user operation. So we would assume that no user is able to manipulate the oracle to their bidding, although many protocols tend to, especially when you use different oracles from Chainlink, they actually tend to actually have that. But fundamentally, once we've done this, now it should be way less likely for us to break it. But at the same time, we're now testing all of these combinations to make it so that we are unable to effectively break this key accountancy or solvency property, meaning that as far as the tool is able to determine, which is obviously a statistical certainty, it's not a guarantee because this is not formal verification, but you still have a lot higher certainty that even though we have most likely some UX issue with the borrowing, right? Because it felt like we should have been able to borrow, so maybe there's more to investigate. But now at the very least, we know that the users are not able to self-liquidate after running the tool for a few minutes. Obviously, we run it for longer, but in general, now this gives us a lot higher assurances than than if we just tried some basic tests. Okay.
No, man, that was a great presentation, and yeah, man, seems like you guys have great product market fit, which is always awesome to see. Like it's needed, and there are many people who can write this stuff. Um, so yeah, I will definitely check it out myself. I'm actually writing something new, and I will need some invariant testing as well. So yeah, thanks, Alex, for this presentation, man.
Amazing. My pleasure. If I can give one word of advice, on one end, for projects, try to contact us early rather than later. It's gonna save you so much money. Don't spend, 6 months in the shadow and then wait for a miracle. But the great advice for all the followers that want to get started is to try create Chimera app. It's a completely free template, but it's a Foundry template that has everything already set up. So you can write your code and then test it very quickly. So you don't have to do all the copy pasting I showed you. So if you're gonna, try it in your own project, try forking off of that, and I think you'll see massive benefits, because it's gonna be literally one click, just get Echidna, and it's gonna run by itself.
Fantastic. Alex, thank you very much. I'm gonna put Recon, the website, GitHub, in the description down below. If you need some invariant testing, guys, check it out. Alex, thank you very much.
My pleasure. Thank you for having me. Happy
Of
holidays.
course, of course. Bye bye, guys. See you in the next one.